Hello everyone, welcome to lesson 212, day 2. We're going to continue talking about transformations of parabolas today. Our goals are the same from yesterday. We want to learn how to transform a parabola. We also want to understand how the graphing form relates to the graph of a parabola and make sure that we know how to perform stretches, horizontal shifts, vertical shifts, and reflections over the x-axis. We're going to start off with some factoring today because this is going to become an essential skill later on in Algebra 2, and factoring needs to become something that is automatic for you, so it should become easy. So we're gonna make sure that we practice it a little bit over and over again throughout the lesson, so that factoring is not going to go away. It's something that we do need to master, so I'm going to make sure that I'm peppering it into every lesson from here on out. Maybe not every lesson. We're also going to talk about completing the square as well, so we'll see those two skills continually pop up here. So let's just factor. Let's factor this. We got x squared plus x minus 6. Now remember, when we factor, our goal is to write an equation that looks like this. Let me grab my pen here. So we want to say y equals, and we want something that looks like this, where we have the two parentheses here. Okay, so remember, factored form has the two parentheses. So we're not completing the square, we're factoring. All right, and the way that we start that process off is we draw our box, and we divide that box into 4 compartments. And I'm going to go ahead and set up my diamond. Okay. So I'm going to take the x squared term that goes in the upper left-hand box. I'm going to take the minus 6 that goes in the bottom right-hand box. So all that's left is this positive x in the middle, so we're trying to find a way to make these two boxes add up to positive 1x. Right? So I'm going to put that in the bottom of my diamond because I need to add to 1x. Now the diagonals, when we factor, right, so a diagonal would be like this negative 6 in the x squared. When I multiply that in this diagonal, I have to multiply to get the same thing in the second diagonal. Okay, so when I multiply this, I get negative 6x squared. So my other diagonal also has to multiply to negative 6x squared. So the two numbers that I put here in this blank diagonal have to multiply to negative 6 and add to give me positive 1. All right, so you have to think of two numbers that multiply to negative 6 and add to get you positive 1. And you might experiment with different combinations of numbers before you find it, but the more that you practice this skill, the faster you're going to become at finding these two numbers. All right, and the two numbers here are going to be 3x and negative 2x. All right, 3 times negative 2 is negative 6, and 3 plus negative 2 is a positive 1. So I'm going to take my two numbers there and I'm going to put them into the diagonal, and now my 4 boxes are complete, and I will begin working on the outside dimensions. I like to switch colors when I transition over to that. Okay, so then remember, the trick here is to think of these as little rectangles, and rectangles have an area of length times width, or base times height, however you want to think about that. So when I multiply my base and height to get x squared, I'm going to need x and x, right? Because x times x gets me x squared. And then I would do the same thing down here. So this is a negative 2x, so I'd have x times something here would give me negative 2x, so this is going to have to be a negative 2. And we'll do the same process over here. X times something has to give me 3x, so this has to be a positive 3. And then I just test that last box. 3 times negative 2 does in fact give me the negative 6, so we're good. All right, so my factors are going to be the dimensions on the top and the side. So the first one will be x plus 3, and the second one will be x minus 2. And there we go. So this parabola and this parabola are the same thing. They create the same exact graph, same exact table. All right, so there's your little mini review on factoring. So let's go back to what we were talking about yesterday with the graphing forms. Remember, graphing form looks like this, where we have this a, h, and k. And I kind of summarize what A, H, and K did from yesterday's lesson. We explored this with Desmos and figured out what each of them do. And I kind of put the things over here. So like if I want to move it right, we're going to make sure we do a minus H. If we want to move it left, we're going to make sure we do a plus H. Same thing with the K, right, and the A value. So if we see something where it says vertically stretch the parabola, we know that we need an A value that's greater than 1. Okay. Some other little things that we talked about, if I wanted to reflect, right, or make the parabola open downward, we've got to put a negative in front of the a value. And if we want to find the vertex, we just need to look at what h and k are. And we'll see an example of that in today's problems. All right. So if you need to read through that again, that's pretty much a summary of what we learned yesterday. And now we're just going to go and apply it in a few problems. Okay. So here we go. First type of problem is going from an equation to a verbal description of what transformations took place with our parabola here. So we have this equation, and by looking at the equation, we should be able to tell what happened, right? So remember this number out front, that's our a value. The 2 is our h, and the -1 is our k value. So this is our stretch and compression, left and right, up and down. Okay. So I'm just going to start with that a value. I notice there's a negative here, so I know it's been reflected. I'm going to say reflected over x. Okay. I also see the 3, right? 3 is a number that is greater than 1, so it has been vertically stretched by a factor of 3. Okay. And I just like to move left to right through the equation. So the next thing here is the h. Since we have a +2, this was shifted left 2 units. So I would say horizontal shift 2 units left. Right. And then I just keep moving across, right? So we go to the k value. It's a -1, so I know it was vertically shifted 1 unit down. Okay. So that would cover all of the transformations that I think I could see from the equation just by looking at it, right? So this is a verbal description of what happened to that parabola. All right, now let's take a look at another one. Let's go the other direction. Let's say we start with that verbal description. Can we go back to an equation? And what I showed you in yesterday's notes was to just start by writing graphing form, right? So remember that generic graphing form that I gave you on the first page of the notes. Right, so this is what our equation is going to look like. I just need to read through those clues and make sure that I can find these 3 pieces of information, A, H, and K. So let's start with this one. It was reflected. Okay, so that means I know I'm going to put a negative here in the front. It was shifted left 2 units. Okay, so this is a horizontal shift, so that's going to be controlled by the H value. And since it went left, I'm going to have to do a +2. So I'm going to replace that h with +2. That will shift it left. Now this one says it was shifted down 0 units, so I could put a +0 here for k, but +0 is just nothing, so I'm just going to get rid of it. All right. If you really want to, you can put a +0 there. It would not be wrong. All right. And then it says vertically stretched by any factor. Okay, so it has been vertically stretched, so I have to pick a factor to stretch it by, right? So I'm going to get rid of the a, and I have to make sure that I choose wisely. So if you recall from our table on the first page, if I want to stretch, it's got to be a number bigger than 1. So anything bigger than 1 will work here. So I could put a 2. -2 times x plus 2 squared would take care of all of the verbal clues that we were given here. Okay, but you had some options. You could have put a 3, a 4, you could have put 2.5, whatever you want, as long as it was bigger than 1. Okay. All right, locating the vertex. All right, so I don't really want to graph. I don't want to look at the table. Isn't there a way that I can just find the vertex by looking at the graphing form? And indeed there is. So we can find the vertex by looking at the h value and the k value here. So I'm going to go down here, and I know that my vertex is a point, so I need an x comma y. The x coordinate is going to be given to me by h, so I'm going to put a 2 there. And then the k value gives me the y coordinate, so I'm going to put a -1 here. Okay. Now you have to remember, for the h value, it's always the opposite of what you see inside that parenthesis. So if it's a +2, that means the parabola was shifted to the left. So this 2 should in fact be negative. So you just have to remember to check that h value. It should be the opposite of whatever you see inside the parentheses. So the vertex of this parabola will be located at -2, -1. Okay. All right, one more here and then we'll call it a day. Can you write the equation if I gave you only these clues? All right, so this is kind of like the other one. We have some verbal clues. We want to write an equation for this thing. So I'm going to start off with my graphing form for a parabola. All right, because I know that this is what my equation is going to look like. I need to figure out these three things again, a, h, and k. So first thing it tells me, one, it was reflected. Okay, there's my negative. And it says the vertex is located at 2, 4. Okay, well, they didn't tell me anything about a vertical or a horizontal shift. They just told me where the vertex is, and that's not a problem because remember, the vertex is located at h comma k, right? So if I have the vertex, they essentially told me what h and k have to be. All right, so I know that this has to be a -2 because it's got to be the opposite of what is in the coordinate here. So if this is a +2, this is going to have to be a -2. So I'm going to get rid of that h, and I'm going to put a 2 there in the parentheses. All right, so x minus 2. And then my k value is given to me by the y coordinate. So in this case it's 4, and it's a +4, so I'm going to keep it as +4. There we go. All right, last clue here. The parabola was compressed by a factor of 0.5. All right, so that means my a value is 0.5. And notice that it said compression. Right, that's because this number is in between 0 and 1. Right, so it was compressed, not stretched. And there's my equation. That takes care of all the clues. This is a valid equation for a parabola that has all of these things. All right, guys, that's it for today's lesson. Make sure you give those practice problems a try. Quiz on Friday. Make sure you're ready. Have a great day.